Assalamualaikum. We meet again for the next subtopic, which is regression under topic 3. Now, before we go further to regression, let us recall back what you have learned previously on correlation. Look at the relationship between two variables x and variable y, where your x is your independent variables and your y is your dependent variables. From the Pearson product moment correlation coefficient, you can identify the momentum or the magnitude of the correlation between the two variables. It's either high positive, low negative, or moderate, or no correlation at all between these two variables. Now, the information from the correlation, which is your x and y, can be bring forward to regression analysis. So what is regression analysis? Regression analysis is used to predict the value of y from the value of x. So in this topic, we only focus on simple linear regression model, where this simple regression model is written as y equals to a plus b x. In this situation, both variable x and variable y must be at least in the form of interval scale. Your x and your y interval scale. This method, the method of least square, used to fit a regression line or equation through a scatter diagram. The one that we have drawn previously in correlation regression. You have a data, so you plot the value of x and y. So this is your scatter diagram. We will use this formula. Y hat equals to a plus b x. And the formula for b is either this or this. And once you have found the value of b, then you can only proceed with the value of a. Because why? Because if you look at this formula, both formula of coefficient of regression a, the value of a is dependent on the value of b. These two information, b and a, is known as coefficient of regression. B value here give the slope of the line, while A value represent the intercept. We represent the information in terms of graph to have a better understanding. So this is your x-axis, this is your y-axis. This is a line. Value here is the intercept. Okay, this intercept represented by symbol A. Okay. The value of y when x equals to, now B measure the slope of regression line. So it means here B measure the changes in y with a unit change in x. So in general, we can say that as x increase by 1 unit, y is expected to decrease or increase by b unit. Now let's say the value of b that you obtain from calculation is 3.652. Therefore, y is expected because the value that you obtain is a positive value. If your calculation, you obtain b negative 21.3675, therefore y is expected to decrease. So the negative signs represent the decrease in Y. Now I'm using the same example from correlation. You may need to look back on this example in previous lecture. Okay, here we have number of leaflet in 1000 unit, and here is amount of sale in RM 1000. Previously we have find the information about this data set and key in the information in calculator. Now let's find the equation of regression line. Recall back, the formula is y hat equals to a plus b x. So here I'm using Excel to illustrate the information. Okay, here is the number of leaflet and amount of sale. First thing, you have to identify which one is your X variable and which one is your Y variable. So previously we know that the number of leaflet here, this will be your X and this will be your Y. And I have illustrated information in terms of scatter diagram here. Okay. Retrieve all the information, your summation of X, your summation of X squared, summation of Y, and total X squared. The formula of B, you have to recall back the formula of B. So I have substitute the information in this formula, and I have the value of B of 2.756. Always take 4 decimal places for regression and correlation value. Once I have calculated for B, I move to calculation for A. Substitute the information in the formula, and then I obtain the value of A. So once I have this information and this information from Y hat equals to A plus BX, you extract here and key in that formula. So this is regression line value. For this part, I advise you to obtain value less than 23, x1 equals to 20 and x2 equals to 35. Choose one value lower than minimum value here and another value greater than value x in your data set. Okay, so when x equals to 20, my y is approximately 42. 42 is somewhere here. I put it somewhere here. Okay, another one will be when x equals to 35. Okay, should be here. My y will be 83. So it will be like this. Use somewhere here. Okay. Make sure you draw using a ruler. One, estimate the amount of purchase if the number of leaflet is 29,000 unit. If you happen to see this kind of information, you look back at this data set. Okay, in this bracket, it take out 3 value of 0. So here you should do the same. Take out this, so it should be your x equals to 29, not 29,000. Okay, be careful with this one. Okay, because your data is into digit information, so your x should be into digit information. Okay, substitute the information using this equation to estimate the value of y when x equals to 29. Use this formula. Take this formula, okay, and for your x here, you substitute with this value, with this symbol. So from the calculation that I obtained, the amount of sale is estimated to be 66,412. Why suddenly there's no decimal point here? Okay, look back. Your sale is in this form. Okay, so if you want to explain about the sale, you have to explain as a whole number that we use here. If in 1000, you should put in 1000. You can also use RM 66.412. However, make sure you put the information of 1,000 ringgit Malaysia 1,000 in bracket because it illustrates the information in here. The last part, interpret the slope coefficient in A. So from our calculation, the value of slope represented by B is 2.756. So what is the interpretation of this slope? So here is the interpretation of slope. Since the value that you obtain is a positive value, 2.756, therefore, we can say that as the number of leaflet increased by 1 unit, the amount of sales is expected to increase by 2.756. So always put back the actual value in 1,000 unit and in 1,000 ringgit. Another information under regression that you can obtain is coefficient of determination, which is denoted by R square. And this value of R square is between 0 up to 1. And from this, from the coefficient of determination, it tells you the proportion of the total variation present in the Y as explained by the regression equation. So to calculate the value of R square, so if you want to find the R square coefficient of determination, simply you just square the value of R that you obtain. Previously, the value of R that you obtained is 0.9365. So you the power of 2, you will get 0.8770. We change this into percentage, so times it with 100, you will get 87.70%. So here, in general, you can say how many percentage of variation in Y is explained by X. So in this case, in the example case, we can say that 87.70% of variation in the number of sale is explained by number of leaflet